Good morning, students. In this lecture, we are going to discuss about the memory and also the memory decoding. Decoding is here how you are having that address, and through the address, how do you enable one particular location or store and retrieve in the memory. Right. Now you consider now we are having a block diagram, a memory unit. The last class we discussed about memory cell, right? SRAM and DRAM. Now here we are going to deal with the total memory unit. Memory unit is you are having that 4 GB, 2 GB memory, right? Now, then how we can go for the overall memory unit? Now, here you see that one. Here the memory unit 2K word. 2K word is, so we are having now 2 kilobyte, right? So we are having now 2 kilobyte word, right? So here we are having here 2 kilobyte 2K. 2K is 2 kilobyte word, right? 2K, this is equal to 2, actually 2 power K. K is actually we are having now the address line. So how many number of address line we are having now? This is 2 power K, right? 2 power K, right? We are having now 2 power K number of words. 2 power K is address line. So here, for example, K is 10 means 2 power 10. So 2 power 10 is here we are having now 1 kilo 1 kilobit, right? Memory, right? So here, if you are having this n line, the data line is 8 bit. So we are having now 1 kilobytes. 1 kilobyte is here. The address line is required as 2 power 10. 1024. 1024 is 1K, right? Now this is here we are having a 1 kilobyte memory, 1 KB, 1 KB. If you are having 64 KB memory, kilobyte memory, right? So 64 kilobyte means here 1024 into 6, right? 2 power 16. 2 power 16. So 2 power 6 is 64. Then 1024 is 1 kilo. Then 64 kilo is here we are having now 2 power 6 plus 2 power 10. So that is 2 power 16. Right? 2 power 16. 2 power 6 into 2 power 10. Right? So that is 2 power 16. Then here 16-bit address line is required. So here 2 power 16. 16-bit address line is required for 64 kilobyte. Similarly, if 132 kilobyte, right? Then it required now the 132, 64, 64, 38, 128, 128 kilobyte. 128 kilobyte is 2 power 17. Right? Then here we are having now 1 MB. 1 MB is 2 power 20. So we require 20 address line. 1 MB. 1 MB is required 2 power 10 into 2 power 10. So 2 power 20. 20 address line is required. 20 address line is required for 1 MB memory. Right, and so on, right? So 2 power 20. If you are having now that one is 1 MB, suppose we are having now like 1 MB and 1 GB, right? 1 GB is 2 power 30. Like we can go for the address line. So here, now you see this one. Here 1 kilo memory with 16-bit data. So the data is here we are having 16-bit, not 8-bit. Here byte. So 2 bytes on together as 1 byte, 16-bit. So this is the content, memory content is 16-bit. So that is 1 word with the 16-bit length. This is the word we are storing now, right? Now here we are having now the address line. Address line is here, this is the 1024. So 2 power 10. So we are having now 10 bits are there in that address line. So 0002 up to the last one as 1. In between we are having the corresponding value. The value is 0, 1, 2 up to that one, and 121, 122, 123, right? Now here, first what we have to do is we have to give the address latch is there. In that address latch, you have to place the address value. Now the address value is enabled the corresponding location. Then whatever the data, 16-bit data in the data line is going to be stored, then you have to give now read write cycle. So here now you see this one, read cycle, write cycle. So if you are giving that read, then we are retrieving that information. If you are going to write, then whatever the data in the input line, the data is stored on your memory. So this is the memory part, right? So this data is stored, and here this 16-bit data on the data line, and you are in. So first we need the address selection, and the 16-bit data in the data line. Then you have to give the write cycle. Then the data is going to be stored in that location. While reading, you have to give the address line, and you enable that one, and you have to give the read cycle. Then it will get that information as. So this is a read. This is a write information we are going to, right? So we are reading that one. The data line is going to have the information of the particular memory word. So this is a memory word, right? Each unit called memory cell, right? So 16 cells are there in that one row. So this is called memory word. So this word is one address. So that address is going to be placed in the address line, and then we are enabling the corresponding memory location, and then we store and retrieve that information, right? Suppose they may ask question about that one as, here if you are having now 64 KB memory, then how many number of address line is required? So 64 is 2 power 16. So 16 address line is required. Similarly, 1 MB, 1 MB ki 2 power 20, then 1 KB, 2 power 10. Then here 32 kp. 32 kp is 2 power 15. Right? Then here we are having 32, 16 kp. 16 kp is 2 power 14. Then here 8 kp. 8 kp is 2 power 13. Then 4 kp, 2 power 12. Then 2 kb, 2 power 11. So one more bit is adding, then it will go for 2 kilobyte, right? So this is 1 kilobyte. So it is actually 1 kilo 16-bit memory. 1 kilo 16-bit memory. So each word is 16-bit memory, right? So this is now here the another, sorry. Okay, next one is here we are having now that memory read cycle and write cycle, right? So how I told you that one. First we have to place here now. This is a clock diagram, right? So clock diagram is here each and every clock pulse one operation will, we can change the data. Here, first we have to place the address line with place the address bit, right? So this address line. So we are having now that around 1024 bit, right? But 10 bit. So we can have now that value. Then if suppose we are want to access that 1023's location, then you have to place the value 1023 in that address line. And then you have to enable the memory. So we have to enable the memory. Now the memory enabled is here in that address line is going to be enabled. So this is the case, right? First clock pulse, we are placing the address line, and also memory enabled cycle is going to be on, right? Then we are having either read or write, right? So here read write cycle in initiating the writing. So here we are going to have the lower is writing. Initiating that writing. Now that in that data input line we have to give the what data you want to store, right? So suppose we want to store the data is in the 16-bit data, we have to store the value should be in that location. Then this value is going to be stored. Then until now for storing it will take time, so you give two more cycle, you wait, and then we'll go for the another operation. So that data is stored on that location. So you have to draw a memory cycle. That memory cycle, what we need is first you have to give the clock pulse. Then we are having that address line. Then you have to enable the memory chip, and then we have to give either read or write operation. You have to give. If it is write operation, then the data line, the valid data is retrieving from the location. We are getting now the data in the data line. So this is the write cycle, right? In that read cycle, read cycle. Here we are having the same way. First we have to put the address in which location, from which location we want that get the data, right? You are storing now. Now from the same location you want to retrieve that information. 1024 is placed here on the first clock, right? Then the next clock is the we are having labs now, right? Then here we memory is enabled. So the same way we are enabling that memory is, you have to make that memory enabled line is going to be high. Initiate the reading. Now that we are ready to read, then the reading the data. So for reading it will take time. Then you have to wait until that valid data is placed on the data line. Now that data line is having that in that one we are having the in data line, whatever the value is going to be stored on memory. Here we are having now from the location what we are having the data is read to that line. So this is now only the data is available in the data line. So we want to process the data, then in that location you have to process. So you have to wait until 2 o'clock, right? So the clock is 50 nanoseconds is required for reading one information from the memory location, right? So this is the write one, this is the read one, right? So here we are having now latched means here that value is, the value is going to be retained until that location. Before that if you are changing that value, then the value cannot be stored. So you have to wait till write. So for write cycle it will take time. So you have to wait the data within the data line until the write completion. So this is the read write cycle. Right. Now, this is a basic memory cell using SR latch, right? The last class we discussed about only simple circuit. Now here you have to go for the latch circuit. Okay. Here. Now you see this one. We are having now, right? We are having now, this is case, right? So here we are SR latch, right? SR latch is set and reset, right? Set is we are having that value 1, right? The reset we are having that value 1, 0. So we can store either 0 or 1 in the SR latch, right? While writing, so you have to give the input data. Input data we have to give S is 1, then R is 0, then it is setting that value 1, right? So that input is going to have the direct input and inverted input, right? Then here we are having the selection line. So you have to select the corresponding cell. So we have to give the selection line on the AND gate. So if you are having selecting, then only it will allow, right? Then we are having now the data, and here and we are having read line and write line, right? So read line. So low is read and write, right? So you have to give now the read write line also. So read write, select, read write, and input. Here also we are having now that one, and is separated up. Then we are retrieving, retaining that value, right, through the inverter. So here we are having now that one SR latch is having now. This one is invert means here for reading we have to give now that read and write cycle we are going to have that value. Then here output is we are getting the data. So on memory cell is in that memory cell you are having the record selection line, and selection line is address, right? Then we are having now, you are giving that input one. If you want to store the data, we are giving the input. Then you want to retrieve the data, it will come as output. So whether you are reading and writing, you have to give no read signal or write signal. If write signal, then it will take the data to store. In the read data, we are whatever the stored in that location is going to get as output, right? Now the overall circuit. So here we are having now this is the diagram for overall, right? So that is a 4-bit word, right? So word is 4-bit. 1, 2, 3, right? So here we are, suppose we are storing the data as 9, right? 1001. Then here stored in the word 0. Word 6. Here we are having now 4 word and each one is 4-bit. 4 word, each one is 4-bit, right? So selection line. The selection line is going to give now the address. So this is the selection. For the 4 bits are selected. First bits are selected now. Then we are having now the read write cycle. So read write cycle, you have to give the signal, whether read signal or write signal, right? So here write signal is we are getting the data to store input, right? If the read signal is there, then whatever the stored is going to come to the line, right? So this is the line we are having now, right? So that is we are going to read the data. So read the data is here data out. This is a data input data. Then this one is output data. Output data we are having now through that line, right? So this is the here we are having now this is a decoder. Decoder is here address line. So we are giving the addresses 00, 01, 10, 11, right? 0, 1, 2, 3. So only address line. So the address line is going to be decoder. So if you are having 00, it will enable that line. If 01, it will enable this line. Then if you are having that 10, it will enable this line. Then 11, it will enable this line, right? So this is a memory enabled signal. So in that we are having that here, right? So that one is memory enabled signal. So the memory enabled signal is going to give now here. Memory enabled signal. Right? Then we are having read write signal. So that whatever that we have seen that one the read write cycle, right? So the in that read write cycle, how that signal is we have to give now. So this is the signals we are giving now as a memory enable read write. Then in that output we are getting the data. Input we are writing the data. So you have to wait until to get the data on that particular line. So for that we are having now this memory read write cycle. So suppose they may ask that basic memory cell using SR latch or just we are giving memory cell, you draw the diagram. So these are 2 mark question they may ask, right? So you use that one, right? And the previous class we have discussed about that how to you have the now that one as one inverter and we are having another inverter in the opposite side and we are having that line and then we are having n mask here, right? So n mask here for word line, right? Then bit line is there, then bit line is going to have this bit line, right? So this is the word line we are having now, right? So this is actually we are having now that n mask, right? Chip cell, memory cell. Here we are having that SR latch memory cell. So using SR latch, the memory cell, the basic memory cell is here. Basic memory cell using SR, using latch or SR latch. So for this diagram you have to, so you have to memorize that diagram. And also here we are having this one type of diagram for basic memory cell for RAM. Right. So they may ask that one then what decoder, right? So you have to design decoder and also here we are having memory. So the decoder is going to select particular line. Then here we are having that address with that bit line. Then we are having suppose 1024 lines are there here, right? So that decoder is here 1024 decoder, right? So 10 address line. So here 10 address line. Now the 10 address line is going to have the line of 0 to 1023 lines we are having now, right? So here 0000, but the 10 zeros is selecting that particular line 1024. So 1024 words are there in memory. Right? So this is a decoder for 10 cross 10, 10 address decoder. 10 address decoder is 2 power 10 outline. 2 power 10 outline is 0 to 1024 line. Then each line is going to enable one particular word. So this is 1024 words. 1K memory. For 1K memory, we record 10 address. For 16K memory, we record 16 address line. So 16 address line is going to give now 1064 into 1024 lines. Then each one is going to connect now. So this is 64K memory. So they want to design the circuit, right? So they will ask that number. If you are having 8K memory, then how many number of 8K memory is required, right? So like they may ask question, right? Then you have to solve that one. We can stop here. We will continue by another lecture.